Welcome to Hartman Math. Today we begin adventures in the wonderful world of trigonometry. We're going to start looking at lesson 4.1, radian and angle measures. In general, we have a vertex, we have a ray that is the initial side. It gets rotated and becomes the terminal side, and that does create the angle. Now our understanding of angles is going to go beyond what we were looking at in geometry, like in Math 2, where we're not bound to 180 degrees. We're also not bound to only having positive angle measures. So in trigonometry, we're going to look at it within the context of a coordinate plane with an x and a y axis, where our initial side will always be the positive side of the x-axis, and our vertex is going to be the origin. And then we'll rotate, and if we end up right there, then that would be considered to be the terminal side. And this is considered to be an angle in standard position. So if we rotate counterclockwise, going this way, that's going to give us positive angle measure. However, if we start here from our initial position and rotate immediately into the fourth quadrant, going clockwise, that's going to give us negative angle measure going in that direction. And then here we're looking at, we've got an angle alpha that has rotated, and there's the terminal side. And beta has rotated the opposite direction, but has the same terminal side. Kind of the same situation here. Both are rotating positive, but angle beta rotated all the way around past one full rotation and still ended up here at the same terminal position. And the vocabulary is not there, but these are called coterminal angles. So both of these depict coterminal angles, where we're talking about two angles that have the same terminal side, terminate at the same location. And a lot of what you've done in geometry or Math 2 has been looking at measures of angles in terms of degrees, which is fine. We'll kind of talk about degrees from time to time, but more likely we're going to look at measuring angles in terms of radians. And we'll talk about why that would be the case, why we need another angle measure. But the definition of a radian is if we have within a circle, and here's our initial side and here's our terminal side, if we've rotated such that the arc length of the circle is the same length as the radius, then that's going to be 1 radian. So the number of radians is going to be then decided by the arc length of the rotation divided by the radius. So the note here is when our measure is 1 radian, then the arc length and the radius are the same. And that's what's pictured here in figure 4.5. So if we're talking about a circle, and if we go all the way around the circle, that would be the circumference of the circle. That would be 2 pi r in terms of arc length. 2 pi r divided by r would give us 2 pi. So if we go all the way around the circle, that would be 2 pi radians. And then if we just start cutting it up into pieces, well, if we just go halfway around, then that's half of 2 pi. That would be 1 pi radians. And if half of a rotation is 1 pi radians, now we go 1/6 of a rotation, which would be 1/6 of 2 pi. That would be pi over 3 radians, and that's right here. Or 1/4 of the way around is 2 pi divided by 4, or pi over 2 radians. So here's some common angles that are shown. So it's a good idea to always think of straight across. We know that to be halfway around, and therefore pi radians. So if we cut up the top of the circle into 6 equal pieces, then each of these is going to be pi over 6 radians. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. If we cut up the top of the circle into 4 equal pieces, then each of those is pi over 4 radians. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And if we cut it up into 3 equal pieces, then each of those is a pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3. So there's pi cut in half, pi over 2, there's pi, there's all the way around 2 pi. Now we don't have to stop here. We can extend these and cut up the bottom into 6 equal pieces and just keep counting around. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9, 10, 11, 12 pi over 6. So you want to be able to be familiar and be able to count your way around the circle and find the angle in radian measure. Also, if we're using these definitions, then any angle between 0 and pi over 2 will be found in the first quadrant, since pi over 2 is straight up, 0 to pi over 2. Anything from pi over 2 to pi will be in quadrant 2. Anything from pi to 3 pi over 2 is in quadrant 3. And anything from 3 pi over 2 to 2 pi would be quadrant 4. All right. Sketching angles in standard position, always show the arrow of rotation. So if we want to get 17 pi over 6, how do we do that? Think about that for a moment. So let's think about it again. Straight across is going to be pi. We want to divide that up into 6 equal pieces. So we're going to have 6 equal pieces on top. So then we just start counting. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then show the arrow of rotation. We went more than one way around, so we're going to start here. Show the arrow of rotation. When it's positive, so we did rotate counterclockwise to begin with. We're unsure about why are we doing it like that. If we just go back, take a look at your pi over 6 and how we cut it up, and just count 1, 2, 3, 4, 5, 6, and extend that. All right, negative 3 pi over 2. So remember, here's pi, but if we're going this way, it's actually negative pi. And then if we cut that in half, here we have negative pi over 2. So negative 1 pi over 2, negative 2 pi over 2. Oh, there we are, negative 3 pi over 2. Always start on the positive side. Don't start your arrow of rotation from the vertex. It starts on the positive side of the x-axis, the initial side, and it rotates this way, and we show the arrow. For the positive angle, 7 pi over 4, how do we get coterminal angles? Coterminal angles will have will end up in the same spot. So if we just go another rotation around, or the reverse, another rotation around, we're going to get coterminal angles. So that's why one strategy, if we want to get a coterminal angle, is we could subtract 2 pi, because 2 pi is one rotation around. So if we subtract 2 pi from 7 pi over 4, we're going to get a coterminal angle. Okay? Just remember that you have to have common denominator to be able to subtract. So we would get a coterminal angle. The 7 pi over 4 is negative pi over 4. So here, rotating, it's kind of hard to see, but it starts here and it rotates there. There's 7 pi over 4. Starting here and rotating this way is the negative pi over 4. And they do end in the same spot. One strategy, we could add 2 pi to get a coterminal. So for part B, taking negative 5 pi over 6, we can add 2 pi to get a coterminal angle. So negative 5 pi over 6 plus 2 pi is equal to 7 pi over 6. So here's our original angle, negative 5 pi over 6, rotating this way. 1, 2, 3, 4, 5. It's going that way. And if we start here and go this way, there's our 7 pi over 6. 1, 2, 3, 4, 5, 6, 7 pi over 6 is right there. If I needed to get another positive coterminal angle, maybe I need 2 of them, I can just take this, add another 2 pi, which is another 12 pi over 6. And I would get 19 pi over 6, and that would also be coterminal. If I wanted another one of these, I could subtract 2 pi again. We could do that an unlimited number of times, adding and subtracting 2 pi to get more and more coterminal angles. Checkpoint, determine 2 coterminal angles, one positive and one negative, for the angle pi over 3. Pause the video here, come up with your 2 angles, come back and let's check. If we add 2 pi, we're going to get 7 pi over 3. The sketch, here's our original. Here's rotating all the way around and then some. 7 pi over 3, if we were to count it. 1. Remember, if we're doing pi over 3s, we're dividing into 3 equal pieces. So it would be 1, 2, 3, 4, 5, 6. And there is 7 pi over 3. If we subtract 2 pi, we're going to get negative 5 pi over 3. So here's our original. Here's going this way. 1 pi over 3, 2 pi over 3, 3 pi over 3 in the negative direction. 4 and 5 ends up right there. Complementary and supplementary angles, vocabulary that comes from previous course, but this time we're going to probably focus a little bit on radians. So 2 positive angles, alpha and beta, are complementary, or we could say they're complements. When their sum is, well, in degrees it was 90 degrees, which is the equivalent of pi over 2 in radians. So they add up to be pi over 2. So if here's alpha and then there's beta, and their sum is pi over 2, then they would be complementary angles. Supplementary would just have a sum of pi. So alpha, beta, added together makes pi. So find the complement and the supplement of 2 pi over 7. Well, if we thought in terms of degrees, and I said, hey, what's the complement to 70 degrees? You'd probably say 20 degrees. And the reason is, you take the 90 minus the 70. Well, here, we're going to do the same thing, but except subtract from pi over 2. Pi over 2 minus 2 pi over 7. We're going to have to get a common denominator for that. We're going to have to change both fractions so they have a denominator of 14. So we get a final answer of 3 pi over 14. Whereas the supplement, since that needs to be add up to be pi, we take pi minus our angle. We're going to get the supplement. So pi minus 2 pi over 7. A little bit easier on that one. Our common denominator this time is 7. 7 pi over 7 minus 2 pi over 7 gets us our supplement of 5 pi over 7. Checkpoint. Pause the video here. Come up with the complement and supplement to 9 pi over 10. think the complement's a little bit tricky. Complements and supplements do need to be physical angles, so they're only allowed to be positive. So which is why for the complement, we would get a negative angle there, which is not possible for a complement. It's possible for an angle, but not for a complement, so it doesn't have one. But it does have a supplement. Pi minus 9 pi over 10 is 1 pi over 10, and that's our supplement. We need to be able to convert back and forth between degrees and radians. And if you're kind of familiar with chemistry, we think of this in terms of dimensional analysis. It's pretty easy. Pi radians is equivalent to 180 degrees. So therefore, if we're trying to convert from degrees into radians, we would want degrees on the bottom so that they cancel, and we're left with radians. RAD is a common abbreviation for radians. You might have already seen it in your calculator at some point, where your calculator has degree mode, DEG. You might have accidentally changed it into RAD, and that is for radians. So to convert from degrees to radians, we'll just multiply by this conversion factor. If we want to start in radians, end up in degrees, we want to cancel radians. Radians would need to go on the bottom. Here's our basic relationship that's creating that. So to convert from degrees to radians, we have 280 degrees. We want to convert that to radians. So we want to use the one that has degrees on the bottom so that the degrees will cancel. So that's this one. So multiply by pi over 180. And then the degrees would cancel. We could probably cancel out the zeros, essentially dividing by tens. So we'd have 28 pi over 18. And that does reduce. Example 4, convert from radians to degrees. So this time we want to get rid of radians. And just a clue, as far as you're looking at an angle, how do you know if it's already in degrees or radians? It's pretty basic. If you see the degree symbol, that's degrees. If you don't see a degree symbol, no matter what, it doesn't even have to have a pi. If it does not have a degree symbol, it's not degrees. It's default radians. So if you see that here's an angle that's 120, that's radians because it doesn't show the degree symbol. All right, so we got radians. We need to get rid of radians. So we need radians to be on the bottom. So we will multiply by 180 over pi radians. And the pi's cancel. And we could cancel a 0 and a 0, but basically dividing by 10. And then we're left with 3 times 18. And we do have the degrees. So this is 54 degrees. And conceptually, we're going to end with arc length. Arc length of a circle is going to be defined to be equal to the radius of the circle times the angle. The angle does need to be in radians. So if it's in radians already, great. It's going to be really easy. Just radius times your radian measure of your angle. If it's in degrees, we will need to make that conversion and get it into radians. Example 5, a circle has a radius of 12 centimeters. Find the length of the arc intercepted by a central angle of 225 degrees. So it's not in radians, so we will use the formula S is equal to R times theta. But our theta, we're going to need to think of that as making a conversion. So 225 degrees times the pi radians over 180 degrees. So radius of 12. Here's our angle. It was degrees. And we are converting that into radians so that the degrees will cancel. And you might be able to take your calculator and just do 12 times 25 divided by 180. I wouldn't do the pi. I didn't mention anything about approximating. So we want to leave this in terms of pi. If we do that, or we simplify, either way, you're going to get 15 pi centimeters. Don't forget your units for our arc length. That's it for today. I'll see you next time.